Next video about the oscilloscope project. Want to make an oscilloscope for measuring purposes. So not an oscilloscope like this, here or that. So a very simple oscilloscope where I want to use the time base of 50 Hz of the mains. Perhaps I want to make a sawtooth generator for a other time base, but anyway. The first idea is always to get the tube working, and that was in this case not very easy. Here is the schematic. I hope it's visible from this distance. And on the background you will hear the oscillator, the high voltage oscillator beep here. I want to make a kind of disclaimer. When you work with a flyback transformer like here, the voltages that get out of the transformer are very high. So say it can give out here 800 volts AC on the frequency where it works, and it is in this case approximately 8 kilohertz. That is in fact a little bit too low. Want to tell more about it anyway. And here is a tripler made with a bunch of diodes. They are in the schematic, and I've used here electrolytics, and that is, say, a kind of dangerous circuit because these electrolytics are charged to approximately 800 volts or 900 volts via the oscillator, the high frequency, the high voltage and high frequency oscillator. So there is a very high charge here. Don't get in contact with with these capacitors. And when you want to make this circuit, do that in a dry room. Wear socks and shoes. The best thing to test high voltage circuits is with one hand in the pocket. So never take with one hand or one finger the minus, and with the other hand or the other finger the positive. Of course your body will in that case act like a resistor. You get these full 800 volts over your body, and that will not be fine, and can even be lethal. So this is a serious disclaimer when you want to make this circuit. I don't show the circuit, the schematic of the high voltage generator. When you want to have it, you can mail me or buy this book. Schematic 3 transistor switches, generators and cathode ray tube circuits. It's on the Lulu website. Here I've used two high voltage, special high voltage power transistors in the generator, and here I've used other transistors, more easy to find and cheaper, etc. But anyway, you can mail me when you want to know more. So that was the first warning. I hope I didn't disappoint too much, because it's a very interesting circuit. An oscilloscope is always very funny and interesting. Anyway, so here is the schematic. I hope it's visible from this distance. So how far am I? I'm as far as this circuit shows. I was talking about the tripler. Here is the tripler circuit. Here is the high voltage transformer. Here is the output of the high voltage transformer via 3 capacitors in a row, and 1, 2, 3, 4, 5 diodes and another capacitor here. There is the tripler. So we have here, parallel to the voltage divider here, that does the job, giving the tube its exact voltages that are needed for focus here, for brightness here. And here we have approximately minus 800 volts. The idea is that the cathode is connected here to the negative. Here the green line to the negative. Here negative, and now to the cathode here. There's a bridge, of course. And here is the brightness grid that is connected via a 2M2 potentiometer. The brightness grid must always be the most negative part, because it here is the electron beam flowing from the cathode to the anode, and anode is the screen. When it hits the screen, the electrons make the screen light up, so we have here a dot. And when there are voltages between the horizontal plates or the vertical plates, the dot will move in the vertical or in the horizontal way. So again, the schematic, now more or less from the upper side, and here complete. My first idea was to use for the vertical plates also the same setup. Potentiometer connected to ground here, and for the vertical down, point 10, pin 10 is vertical down, pin 11 on the tube is vertical up. We are talking about this tube, this type number. And I want to show the tube again. I think it's important. So here is that tube again. And the strange thing with this tube, this is the B7S2 tube from Eastern Europe, I think made in the 1970s, 1960s, I don't know that exactly, but anyway, here is the datasheet. And here we have all the S.E.I grids. And when I say grid, don't think that it is a kind of mesh. Inside these tubes are, say, this cathode ray tube. There are, say, silvered or so tubes, and that do the job. So the focus grid, the brightness grid is not a grid, but it's in fact a very small tube. The strange thing of this tube was that I had expected that this were the vertical plates and these the horizontal plates, but that was reversed. Very strange, because normally the horizontal plates are here and the vertical plates are here. They are more far away from the screen, and that means that their sensitivity is somewhat higher. And in fact, at the moment, I'm not completely sure that I've done it all in the right way, but it works, and that's very important to tell. So pin 8 is horizontal, pin 7 is horizontal, and the other plates are vertical. So the tube socket again. Hope that will help. Want to refer to the earlier videos again. Say the bare basic info of this tube. Everything is rolling around, but anyway, this is the info. I don't show the absolute maximum ratings, they were in another video. These are, sorry for all the movements again, the normal settings of the tube here. Betriebswerte, that's German for, say, the standard way that this tube has to work. You can see the filament voltage, the filament current, and relevant voltages. So, back to my schematic. Took me 2 days to find it out, to get it working. So again the schematic. Pen over somewhat here. The cathode, the focus grid, the vertical down and the vertical up plates. Strange that, in my opinion, the horizontal and the vertical plates were not on the place on the tube, on the schematic that I had expected. But anyway, this works nice. Worked nice. So you can send in here between these two electrodes, here and here, a horizontal voltage, and I've done that by using this sine wave transformer here. So now we have between the horizontal plates approximately 50 volts AC, and that means that the electron beam here, that starts here and is deflected here a little bit, normally via the vertical and the vertical plates to the screen. I have not used the vertical plates at the moment, and I mean I've not made here, say, the resistors that I want to make there, but anyway. So the electron beam moves, hits the screen, lights up the screen, etc, etc, and we can set here in a certain way the sensitivity of the horizontal plates, because there are two potentiometers here that are connected to ground. I cannot stress enough that the schematic is key here. Looks a little bit problematic perhaps, but it is not. And set your resolution on YouTube to the highest resolution, so that you can find all the, say, right component values, etc. 0.7 microfarad, 3 times 400 volts. The diode is 1N5408. These are 3 electrolytics in a row. They can handle all, say, 400 volts up to 450 volts. This is the voltage divider, very, very important. This is the focus grid. Here, this line to the focus. And here we have the brightness grid here. The brightness grid is connected to the most negative part, so it must get more negative than the cathode. Because when it is maximum negative, all the electrons that leave the cathode cannot get through. They are repelled back to the cathode. Anyway, so that was enough about the schematic and, say, the dangers of making such a circuit. You can make it, by the way, when it lies completely free on the table with wiring, etc, etc. So this is the experimental situation. Of course, after a moment I will make this all again and then very neat, but this is, say, the way to get it working. What are the issues with this very simple thing? Well, at first let me show when I give more voltage to the horizontal plates. Of course, the horizontal line moves, stretches out. Anyway, the issue is in a certain way that we see here on that screen the, say, 8 kilohertz out of the oscillator back. So it modulates the line. Does not have to be a problem. Was also never a problem in earlier oscilloscopes that I made. By the way, in these cases I did not have this problem, because I went to, say, approximately 18 kilohertz, and this one works only on, say, 8 kilohertz, and that means that here we have that, say, typical line. But when you switch the oscillator off, there's still a lot of charge on the electrolytics, and that's why I've used electrolytics. So I switch it off, and now we have a pure line without all these, say, intermodulations of the other frequency. So again, let's look. Switch the the high voltage generator on again. We have here all these, but there is a moment, my camera can stop suddenly, but anyway, there is a moment when I bring back the voltage of the generator, the frequency goes higher, it gets more ideal in relation to that 16 kilohertz high voltage transformer. So, and that means the frequency gets higher and all these, say, intermodulation disappears. But anyway, for the application that I want to use this is not a serious problem, because I want to make a switch that I can switch the voltage supply out. Now you have a beautiful line here that can be used for all kinds of measurements. Based on a book of 1942. Anyways, thanks for watching. Quite long video. I didn't want to make it so long. A lot of work to get all the potentiometers right. What is the positive, the negative? Where are all the grids? And of course also because the information of the tube was not very clear. So again, the schematic, and thanks for watching. And perhaps this will work here, and I'm not sure about it. So flip this back. And I want to show, by the way, that when you touch the plates here, you see this. So this is the up plate. Touch the plate. I want to keep this high sensitivity. The up plate, here's a down plate, vertical down, vertical up. And I want to keep that high sensitivity, but when I connect a 1 mega ohm potentiometer, all that extreme sensitivity is gone, and in fact I don't want it. So I have to find that out. Thanks for watching again.